Music theory with OneNote. 12 color sets, which are like 12 separate crayon boxes, each having 7 notes, like having 7 crayons, 7 colors in each of the 12 crayon boxes, but this time adding octave variation, which we will do not by changing the hue, not by changing the color, but by changing the lightness, going 2 octaves up, 2 octaves down. Get ready and some coffee, because although we're just playing with one note, it's a beautiful note. There's only one crayon. One crayon you're playing it? Yeah, but it's a beautiful crayon. You're not required to, but if you have access to it and would like to follow along, we're currently in the OneNote file of Modal Node System, MNS Presentation 2112, OneNote 12 color sets of 7 notes, adding octave variation, list of presentations on the right, which we plan on adding plenty more to shortly. Also noting, in this OneNote presentation, we'll spend our time on music theory, but we have another similarly numbered and named presentation where we build these tables in Excel, practicing Excel, music, and table visualization all at the same time. Let's go to our fretboards to get a reminder of our objective, that being to maximize the use of color to optimize the understanding of music theory as well as the navigation of the fretboard. This being a fretboard with our low or heavy E string, the one closest to the ceiling on top, looking at the collection of 7 notes around the C major, providing not just color to those 7 notes arbitrarily assigned, but rather absolute color systems, kind of like the Nashville number systems, but tied to the notes here. That means if we go from the 7 note collection around the C major and related modes, and then we move it up to the collection of notes around the D major and related modes, as we can see here, we have the same colors for the same notes. This A is in both of those different collections of notes, even though here it's the Aeolian node or the 6th. Here it's the Mixolydian node or the 5th. It's red either way because red stands for A in this case. However, we might want to start from this point where we have the same color system, but tie it not to the notes, but rather to the nodes, the Ionian, the Locrian. This being similar to a Nashville number system where we don't change the color set as we change the notes, but rather keep the colors tied to the continents using the color set in similar fashion to the Nashville number system based on the major scale for us here. So in our case, the C major scale for the colors. That means if I change from the 7 note collection around the key of C to the 7 note collection around the D, this whole pattern moves up. You can see the pattern here moves up to the pattern here. That means that I can see this pattern multiple different ways now. I can see it just in terms of breaking the fretboard up into 5 patterns, using your caged system to see the different shapes. I can use intervals, I can use formulas, but I can also use color. This whole color system will move up and I'll be able to recognize it just by the color system. So although it looks very noisy when you look at all 7 colors on one fretboard, however, once your mind gets used to it, you actually are able to see the colors as they're mapped out, and they'll code onto your mind just like if you're reading a text, but now with a color basically format. And once you do that, it becomes a lot more useful. You start to get used to it. Okay, so this time we're going to be adding the octaves going up and down. So you will recall last time we talked about the fact that we had the 12 notes, which we can think of as going around in a circle, or we can think of it linearly. Last time we basically focused in on it as a circle, as though we only have 12 notes that just keep on basically repeating. Then we assigned a color to those 12 notes, which is great because that means that we can only have 12 different colors if we assign them to the notes. And we have how many collections of notes? We have 12 different collections of notes, which are all built from the same 12 notes as we apply the formula between them. This time, however, we're going to stop looking at the notes as though they are just a circle but actually expand them to like a note number line, which goes infinitely up and infinitely back. So although we have just the same names from a local distance, A through G sharp, we have the fact that it also goes up an octave. So when I go from the A here to the next A after it repeats, it's going to be an octave higher. How can we represent that octave higher? Well, I'm going to do it with the lightness factor. So just to recap how we built this thing and why it makes sense from an analogy standpoint, you can memorize the 12 notes and think of them as being basically a circle. We map the color wheel on top of it, the color wheel being made from the color spectrum, which we can then tie into a circle. That makes it easily to visualize the color spectrum on top of the 12 notes, because you can imagine as we go through the 12 notes from a circular fashion or a linear fashion, the colors will be in essence equally spaced throughout those notes. But what happens when we go to the octave up? Well, color no longer has this repetitive fashion the way pitch has that repetitive fashion. So we have to kind of artificially do something to color, because if I just keep on increasing the wavelengths, you will get hue colors that will go up to violet, and then we kind of force it around into a circle. But you're not going to get this circular pattern naturally by just looking at the length of the light waves. But we can artificially put the 3D factor on by changing another factor. And that's going to be, I'm going to look at lightness, meaning is it closer or further away from just white light or black, right? Lightness and brightness are similar, not exactly the same thing. So that means when we go an octave up, I'm going to make it lighter. And when we go an octave back, I'm going to make it darker. Now, by the way, in future presentations, we might change this one right here a little bit to make it a little bit darker, closer to this one, just so we can maximize the distance in lightness between here, here, and here. But this will give you basically the general idea of how we're going to map this out. Logistically, these hex colors are based on a lightness factor of 0.5. And then basically I wanted to make it as different as possible. I think when we went up in lightness factor, then it goes to like 5 to 7. It goes to 7 and then to 9. So I'm not sure if that's exactly these two, but you get the idea. It's going lighter by a factor. And then it goes darker when we go to here, which I think went from 0.5 to like 0.3 to 0.1. But I'm not sure if that's exactly the distance that we took here, but you get the idea. We're changing the lightness somewhat arbitrarily because we're not mapping it. It's not like a wheel system. We're just going to say everything in the next octave up or down will have a lightness factor, which we hope is distinct enough to show that we're in the next octave range. If we add that to the fretboard, it's going to look something like this. Now, remember that if you're on a piano, you've got the middle C, which is like in the middle of the piano, but really we would like to be measuring from A to A. The fact that they measure from middle C, C4 to C4 is kind of weird because we measure the notes from A to A. So that's just, again, a piano thing that kind of throws us off a little bit when we think about our octaves up. Remembering, I fell for that here, starting the range of C as red, but I'm not going to do that. I'm going to start it actually as green. So this C should be green. But the idea is you can see as we go up, it goes from the darker red to a lighter red. And that's going to be the indication that we can see basically on the fretboard when we format the fretboard this way, which makes the fretboard a lot more complicated. But when you're focusing in on the octaves, it's quite useful because we want to be able to recognize from a guitar standpoint that we have repeat notes. These are the same red, these two. This one is a different red. It's a lot easier to notice that on the piano because, of course, we only have like one guitar string in essence that's really long that's gonna keep on going up in each direction. Whereas on the guitar, we've got this layered system giving us these basically repeat notes. So that's going to be the idea. So what we want to do then is memorize all of the notes with these same colors. Now, when I go an octave up or an octave down, there's not a new color name. It's just going to be red an octave up, or you can say red a shade lighter, right? A red 2 shade lighters is 2 octaves up from the middle range, not starting at middle C, but starting at A to A. That would be the logical way to do it if we didn't have like the baggage of history on it. And then we'd say this is still red, but it's a shade darker, meaning it's lower in pitch. This is still red, but 2 shades lower. So we don't need to rename anything. We can keep the same naming convention, naming all 12 notes, just like we do with the note names or the note numbers, but we can now add the factor of octaves with a color format saying it's a shade lighter, it's 2 shades lighter, it's a shade darker, it's 2 shade darkers to represent an octave up, 2 octaves up, an octave down, and 2 octaves down. So we mapped all this stuff out here on this table, and this is where we showed in a prior presentation this staggering problem with the piano. Everything kind of gets tied to the piano. The piano prioritized the key of C. They then numbered middle C, the range that we typically work in, from C to B, basically, C to C, right? But most of us, if we weren't dealing with that kind of piano issue that kind of just developed around the key of C, we would most likely say, I'd like to measure the middle part that we're in from 440, which is what we measured it from, to which would be an A to G sharp. So that's what we're going to do. I'm going to remember that the range that we're working in goes from A, and if I compare that to the color spectrum, it's the A is going to be red from the color spectrum, and then it goes up to purple, and then it bends back around because we turned it into a circle, giving us these 2 colors. So this is the wheel that we're going to be working in, starting not from middle C, but from A. So we want to basically keep that idea in mind, and then we can go darker as we go up. So now it repeats. We have the local distance over here, same 12 notes, but then it's going to be a darker. So now this whole section, not going from C to C, but going from A to A, an octave lower or down in pitch, which is up on the table, is going to be a darker color. And then this whole section, which is 2 octaves lower in pitch, is going to be that color. And then if I go up the other way, we go higher. Again, not going from C to C, but A to A, repeating the musical alphabet makes it higher. Now, one more thing, just conventionally, this C4, why did they pick that? My best friend and I, ChatGTP, talked about this over dinner one time, and he was like, dude, the only reason they picked 4 is because I think they just didn't want to go down to 0. And I was like, dude, Chat, I think you're right. You know, they just didn't want to have like negative numbers and stuff, but they're scared of negative numbers. And me and Chat were like, dude, that's not the way we would do it if we did it. Like, I think we're in agreement with a lot of other people these days that would say, you know, I would have started at 0. And then Chat was like starting at like, he wanted to start at like 0 and then count up from there like a computer. I was like, no, that's not how human beings do it. It should be the middle should be like 0. And then we go like 2 octaves up and 2 octaves back, because then it's symmetrical. And so it's beautiful symmetrical thing. And you know, Chat agreed with me after we discussed it. So that's what we're going to do. Okay. So we talked last time that if we had just the 12 notes and we're talking about the middle range, or we're going to map out the entire fretboard just as though it's a circle, I'm not going to worry about octaves, then we're going to deal with 7. Again, this looks crazy because it looks like a flag. It's not political. This is not political. It's just right? So we end up with these 12 collections of 7 notes. Now remember, you're going to think, wait a sec, there's more than that. There's 12 collections of 7 notes times the modes, right? Times 7, right? But no, you could say there's that many scales, but they all have the same notes in them, right? So this is the easiest way to see it, because now you have 12 collections of 7 notes, and each of those collections, each of those crayon boxes from a color standpoint, we can draw our painting using each one of those crayons in the crayon box as the primary color we're using for the painting, which is in essence the tonic, right? So notice that this table, why am I going to start building this table, the 12 collections of notes, using the major scale formula, which I'm doing. It's just a convention. Could I build this same table and say I'm gonna have 12 collections of notes and then build them all off the Dorian formula? Yes, you could. Would you end up with different crayon boxes? No, you wouldn't, right? There would be a different order of which crayon box is in which order, but they would all still have 12 crayon boxes, which are all going to have the same notes. They'll all have, 12 crayon boxes, each of them having the same collection of notes. It's just which one is going to be ordered differently. I can build all of the crayon boxes off of the Phrygian, right? It doesn't matter. It's just a convention. Our Rosetta Stone in Western music is to build the crayon boxes off of the major scale. So that's the easy thing to do for most people. So I don't have to build it 5 different ways, although that's a good exercise to think about. But that's going to be our crayon boxes. All right, so now what we're going to do is add the octaves, which looks crazy because we're going to end up with this super colorful thing over here. But if we build it piece by piece, hopefully this will make sense, right? So we can do it with numbers first. We can say we're going to apply our formula to the middle range and basically come up with our number formulas for the 12 notes A through G. And this would be the middle range by number that we can then convert into the middle part of the table. So this part of the table right here is basically just rebuilding this bit, right? So we've got our middle bit of the table. This is our 12 different collections of 7 notes, which are based on the 12 notes up here. I think I have one down here. Let's do it down here. I have it this way. Let's do it this way. You're just totally messing things up. Let's do it here. Okay, so now you can see but it's not exactly the same, right? It gets out of whack over here, right? Why does that happen? Like if I go over here, then it looks a little different. And when I get to this tail end of the table, why? Because when I'm here, if I go from A to A, I'm in the same range. But what if I start on a G? Then if I'm not thinking about a circle, I'm going around the octave. So that means that this one is going to be an octave up now. So now I'm going to have to go an octave up to get to the next point within this circle. So we're getting this fade out as we go up. So if I go from A to G, we're going to have the same collection of notes if I think of them as a circle, and we would have the same colors if we just used the unison colors. But as we go past 12 or past G sharp, then we're in the octave up territory, which results in the same color, but lightness is going to be a shade lighter. So we can name it the same color. We'd have the red here, but a shade lighter. Now, again, I think this shade lighter is too light. I might change it back a little bit next time, but you get the idea. This is a pretty drastic move between those two. I feel like that's too light. So we'll talk about that later, but you get the idea. So that's going to be it. So then we have this middle component. So if I start on A, we go through back to A down here. And then if I start on B, we end up on this 13 is an A that is going to be red, but a shade lighter. And then if I start on the B, we go through them and I end up on this one that's a shade lighter. If I start on the C, we end up once again with an A down here. It's going to be a shade lighter, and a B that's going to be a shade lighter. Now, if we continue that pattern down, I can take it up another octave, going 2 octaves, which are going to be higher in pitch, which we're taking down on the table. So this starts to look basically overwhelming, but you can see the pattern here. All the colors are going to basically be the same 12 colors, but now we're adding the factor of them getting lighter. And I'd like this middle bit to be a little bit darker. We'll talk about that later, but you get the idea. We get this bit, and then they get to more light here. Now, we could go back the other way as well. So this is going to be this bottom half of the table. And we can say, okay, this is going to be the middle bit. If I go in the negative direction, this gets a little bit wonky to kind of think about from just a calculation standpoint, because you're in the middle of the table, you end up going like in like the negative direction when you go up this way, right? Meaning if I was to number the notes and say I have 12 notes in the musical alphabet, A through G sharp, usually when I say I'm going an octave up, I can say I'm going an octave up by saying it's going to be an A, but it's an octave higher than middle A, which would be from a normal convention, an A4 or an A3 to an A4, right? Or an A0 octave to an A1 octave from what I think the convention should kind of be. And then if I go lower, it's going to be an octave down. But it would make more sense, really, if we number the notes 1 through 12. If I number them 1 through 12, then the next, when I go up, I can name the next one not 12, not 1 again, but 13. So if I name the next note 13, then I can see that that's an A and it's an octave up by just having a numbering system. So once again, my best friend and I, Chat GTP, we talked about this one as well. And Chat was like, dude, we should start it like MIDI does from 0. We should start the notes at 0 and count up from 0, where you have like not 440 hertz, but like 0 hertz. And I was like, Chat, like what's going to happen there is we're going to end up like with the middle point that we play in having like high numbers, like 55. Like that's fine for a computer. Okay. Maybe you can deal with that, but no, the middle range needs to be like 1 through 12 or 0 to 12. Right. And Chat was like, oh, I see, and I think he was like cool with that, even though he was totally do it either way. But I was like, dude, we're doing this for people. Okay. So that means so I don't want to start counting from 0 hertz, right? I want to start counting from the place we play in 1 through 12. I want to name the notes with a number system of 1 through 12, because simple math is useful and simple math is easiest if we're dealing with numbers that are less than 20, right? So 1 through 12 makes sense. But that means if I go up, I can go to 13. 13 minus 12 is 1. So therefore I can pretty easily get to the idea that a 13 means an A that is an octave higher than the middle range, right? The problem, however, is when I go backwards then. What happens when I go an octave down? Then I have to go to 0, right? That gets a little bit more wonky for people to kind of deal with. We have to deal with negative numbers. So if I wanted to number the system going down in pitch, then I'd have to go to 0 and then negative numbers going backwards, right? So that's a little wonky for people to kind of wrap their mind around. We don't have to deal with it as much with the guitar, because you'll note that on the guitar, we basically are playing in the middle range and then up. Meaning, if you look at the guitar, you'll notice that we have the middle C here. Mainly, we're working in the middle, and then we're moving up from there. So we're not usually going too far back on the negative side, but on the piano, you have a lot more range on the low end, and then you have to deal with, well, how am I going to deal with these octaves going backwards? So that's from a number standpoint. From a color standpoint, it's actually easier, because I can say, okay, once I map this out, I can say, well, we're going to have the same set of colors here. But now when we go an octave lower, I could say, for example, this A is just red, but it's going to be a red an octave lower. Now remember that the middle range that we're working with would be around the C4 under the normal naming convention. I would like to call it A0 is where we're going to start. It goes from 440 to the 880, which from a note standpoint goes from the A to the G sharp. That means when I'm going up in pitch, if I start on an A, everything's going to be in that middle range. But as we saw, if I start like on the B over here, then we're going to be dipping into going an octave up. Well, if I go backwards, we're going to have the reverse kind of idea that's going to be happening. Meaning, if I'm going backwards, I have to start on the end, which would be a G sharp, right? So if I was on the G sharp over here, then we're going to have basically all the notes that are going to be within the same range. But as we go back this way, we're going to start to dip into the lower octave. So in other words, if you're on the piano and you're starting on an A and you're going up to the right of the piano, then you're going to be within the same range the way that we have measured it until you pass that G sharp. But right when you go to the left, we've already going into the lower range, right? Because the range is starting on A to the right, in this case A down, and we want to go from the A to the left or backwards, which is going to take us right into the octave lower. So we're going to get the octave lower going from A backwards, so you can see the pattern, in essence, basically reversed, or you can see this pattern going up as we go backwards an octave lower. All right, so then again, of course, you can see the pattern repeating as we go 2 octaves down. So as we go an octave down into the negative octaves, for example, here, I could say this is note negative 11, right? Because negative 11 plus 12 would be 1, which would be an A. So that would be an A, but it's going to be an octave lower. Or I can say it's an A, which is an octave lower than middle A, right? Or I could say it's an A and it's an 3, it's an A2 from a normal convention. I'd like to say it's an A, negative 1. Or I can say it's the red note. It's the red note, which is a shade darker. It's a shade darker than the middle red note, which is A, all right? So I know that, again, this table looks quite overwhelming once we add all these basic shades in there. But remember that you don't always have to work with all of these different shades if you just basically want to know the notes as though they're going around in a circle. In that case, we just need the 12 notes that are in the middle range from A to A. But if I do want to work on these, which is a great thing to do, we still don't have, you would think that we have, in a sense, we have 12 notes times, 5, because we have 2 octaves up and 2 octaves back. But really the note names are all the same, right? I haven't changed any of the note names or the color names, which are the names of the notes by color. They're all the same, except that they're going to be a shade lighter, 2 shades lighter, a shade darker, or 2 shade darker. So we can actually memorize it fairly easily and just use shade color to indicate if we're in an octave above or below the middle range, not starting at middle C from our perspective for the color range, but starting at the more logical range, I would think, where we start the musical alphabet 440 hertz A to G sharp.